Good morning, everybody, and welcome back from your, I'm using air quotes, spring break. So, what I have for you today is some more solid geometry. As I scroll through, many of you will see the cones that you uploaded last week. I appreciate the creativity some of you use when you couldn't find your own at home. I like the people who made theirs. There were a couple of more that people made too that I put on. I like the creativity of this banana, just looking at the top part of the water, somebody's conical tree. So good job, guys. I like it. And I mean, most of these aren't perfect cones, right? A lot of these have the tops cut off. They're called a truncated cone. Some of them might not be perfectly circular on the bottom, but I like what you guys did here. So good job. So yeah, cones today. And this first part where it says triangle ABC is shown in the diagram below. Okay, ABC. If angle CAB is a right angle, what three-dimensional, spelled incorrectly, objects will be generated if ABC is rotated about ED? So if you can picture taking this line, this segment, and spinning it around. So you would spin this triangle around this line. I mean, hopefully, and like the hint is, we're doing cones today. Hopefully you see that it would end up forming a cone. There would be a circular base. And wow, I mean, that's bad, huh? So it would be like a mirror image over here, circular base on bottom, go up to a vertex on top, and it should create a cone. The reason I'm doing these is because when you get to calculus, there will be rotations of objects around an axis. So I'm hoping that you'll just start to visualize what will happen here. Okay? Now, cones. Here's my nice little diagram of a cone down here. Take a look at it. Okay. Now, there's some terms that you should be familiar with. Vertex, obviously the top point. We know that there's a radius down here of the base. Now, the height, this is like the altitude, right? It forms a right angle with the base. So this is the height. And then over here, they call the slant height of a cone. When I'm using the term height in any of these formulas, I'm going to be talking about this height. Sometimes you'll be given the slant height to work with, but the perpendicular height to the base is the important one here. So, I'm not going to ask you for the whole surface area of the cone. It gets a little confusing, but you should realize that the surface area of the base is what? Here's the base. So the area of that base, since the base is a circle, the area of the base is what? Pi r squared, where r is obviously the radius. Now the volume of the cone is very interesting, and I'm going to try to look for a video that shows this because I would normally do it in class, but I don't have all the geometric shapes here to do it at home. The volume of the cone starts very similar to the volume of the cylinder. So the volume of the cone. You're still going to take the area of the base of the cone, and the base here, we just said, is pi r squared. You're still going to multiply it by the height, which is this height over here, remember? But it turns out the volume of a cone is just 1/3 of a cylinder. So if you picture, try to draw here for you. If you picture this being a cylinder instead, it turns out the cone only fills up 1/3 of the space of the cylinder. So what I would normally do is I would take a cone, fill it up with water, and show you that it takes 3 of those cups of water from the cone to fill up the cylinder. Okay, so I'll try to find a video of that because I don't have this stuff at home. So here is my volume of a cone. Yeah, it's given to you on the formula sheet too. So I'm going to go through one example and then I'll give you guys 2 examples to do. And for this one, I'm just going to change it up for you a little bit. I'm not going to make it as easy as I could. What I'm going to say is I'm going to say that the slant height of this cone is 13 inches. Okay. And I'm going to tell you that the radius is 5 inches. And I'm going to ask you to find the volume. Okay. Now, I know the volume is going to be 1/3 pi r squared times the height. Okay, well that's easy. I have the volume is 1/3 pi. The radius is 5 squared. But this over here is the height. I don't have the height. Can you think of a way that I can find the height? Well, this should be a right triangle, and I know 2 sides of a right triangle. So, hopefully you're thinking Pythagorean theorem. 13 squared equals 5 squared plus h squared. You can solve for the height, or you know that this is a Pythagorean triple if you've done enough practice with that, but you don't have to. So go ahead, find the height for me. $169 equals 25 plus h squared. I subtract over, I get 144 equals h squared. Take the square root. The height is 12 inches. So, plug that in for the height. So, if I multiply this out, I get that the volume is, I'm just going to multiply all the numbers, 1/3 times 5 squared, 25 times 12, I get 100 pi inches cubed, because I should have written the units in here. Now, oh boy, This would be the exact value, or the exact volume, or this would be in terms of pi. But let's say you were asked to round to the nearest cubic inch. Then I would put 100 times pi, use the pi button, don't use 3.14. It's on the bottom by your keyboard. 100 times pi, and I would get the volume is 314.159 inches cubed, which I would round to 314 inches cube, or cubic inches. This is an approximate value. This is not the exact value because I rounded. That's the difference between exact value and a approximate value.